Alrighty, so let us get started with our simplification. Like I say, don't stress about getting the questions down. We're going to do each one so you will get them. Right, so when we simplify expressions, there's three important steps that we need to follow. Those are to identify the terms in your expression, so identify how many terms you're working with. Then we want to be able to simplify each term. Now, it doesn't necessarily mean that every single term must be simplified. Some of them just aren't simplified because they're as simple as they can be. And then we want to simplify the whole expression by adding and subtracting our like terms. So if we can do those three things, we should be sorted to simplify our expressions. Alrighty, so we're going to start with question 1. Whoops, there we go. And we're going to simplify. So the first step is to identify your terms. Now, if you don't do it like this, that's not the end of the world. It's absolutely fine. I just find it easier to make sure that we remember to simplify everything that we simplify. So if you are feeling brave, you can raise your hand or you can pop it in the chat. Does anyone remember how we can, or what separates terms in an expression? Okay, I'm seeing some on the chat, 4 terms. Yes, indeed. When we are looking at terms, remember plus and minus signs separate our terms. So the plus sign and the minus sign, those are what separate our terms. Awesome, guys, well done. So that then means that in this expression, as some of you have already said, I have got 4 terms. Whoopsie. In my expression. And once I know what terms I'm working with, I now want to check whether or not I can simplify any of those terms. Now, when we want to simplify terms, there will be things like brackets there or exponents there, or maybe a fraction. And if I look at this, none of those terms can actually be simplified. So I can sort of jump straight to my last step where I now go and simplify the expression. Now, this is where if you're someone who likes color in your maths notes and likes highlighters and everything all over the place, that's absolutely fine. I am that type of person. So I'm going to grab a highlighter and I'm going to highlight for myself like terms. Now, remember, guys, like terms are terms that have the same variable and exponent. So in this case, the 3x and the plus 5x are like terms because they have the same variables. They both have x's. On the flip side, I've got a 2 and a negative 4. Now, those are what we call constants. So they form a new group of terms that are like terms. And so once I know what my like terms are, I can now go add and subtract them. If you feel more comfortable, you are welcome to put the like terms next to each other. So you can write it as 3x plus 5 and then plus 2 minus 4, just so that you can see clearly what your like terms are. And then we can go and add and subtract. So if I start with the x's, 3x plus 5x, what you need to sort of think of it as, I've got 3 x's in one hand and 5 x's in the other. And if I put them all together, how many x's do I have? Well, I've got 8 x's. Okay, so 3x plus 5x is 8x. And then I go and subtract the 4. So I've got a 2 minus 4. Again, how you're more comfortable doing this is up to you. You might be able to use a calculator. Some teachers are fine with you using a calculator. I'm absolutely fine with calculator. So if you want to use one, you can. Otherwise, you can think of addition and subtraction in terms of a number line. So if I've got my number line here and I'm starting at a positive 2 and I want to take 4 away, I'm moving towards the negatives. 1, 2, 3, 4. And so what I see is that when I take 4 away from positive 2, I end up with a negative 2. Now, we always just double check and make sure we can't simplify any further. And what I'm essentially looking for here are like terms. Do I have any more like terms I can add and subtract? Well, if I look at my answer, I've got an 8x and a negative 2. There's no more like terms there. So exactly, no, that is my final answer. So I've simplified my expression. So well done, all of you who are putting 8x minus 2 in the chat. That's awesome. Well done.
Hi, ma'am.
Hi.
Ma'am, I wanted to ask by the second, when it was 3x plus 5x plus 2 minus 4, how were you able to get the answer 8x minus 2? Because 3x plus 5x is 8x, but then what happened to the 2 minus 4?
Okay, so remember, those are separate groups of terms. So if I go back to what I'd highlighted, the 3x and the 5x are one group of terms. That is then completely separate to the other group of terms that I'm working with, which are the constants, the 2 and the 4. So when I add them together, I can't actually say, okay, well, I've got 8x, now I'm adding 2, so I've got 10x, and then I'm taking 4 away, so I've got 6x, because those are not like terms. I can only add and subtract like terms. So I have to keep the x's and the constants separate. I can't put them together. Does that sort of answer your question?
Yes, ma'am.
Okay, good. Well done.
Thank you, ma'am.
Alrighty. Okay, now when we are writing our answer, if you had put this in a slightly different order, that's fine. So if you had put minus 2 plus 8x, that is the same thing. And so that's absolutely fine. But what is very important is that the 8x is positive and the 2 is negative. That is what's really important there. Alrighty. So if you haven't got that, take a screenshot that you've got the answer, and let's have a look at our second question. Okay. Right, so again, what we want to do is figure out how many terms we had. So you can put it in the chat or you can raise your hand if you're feeling brave. But my question to you is, how many terms do I have in this expression? Okay, Ryan, I saw your hand go up. Do you want to tell us? Seen some great answers.
Yes, ma'am. We have 4 terms, ma'am.
Awesome, well done. Okay, guys, so we've got 4 terms. Remember, those plus and minus signs separate my terms. I don't know why my pen's disappearing. So this is my first term, second term. Okay, there we go. Right. First term, second term, third term, fourth term. So now I know what terms I'm working with and how many terms I have. Now, none of those terms can be simplified. There's no multiplication I have to deal with. There's no division, no exponents like in brackets or outside brackets. I do have x squareds, but I can't simplify that any further. So my next step now is to identify my like terms. So remember, like terms have the same variable and exponent. So 3x squared and minus x squared are like terms, but in a completely separate group, I've then got the 2x and the minus 7x. And they have to be completely different because hopefully what we notice is that those x's do not have the exponent of 2. They don't have the squared. And so because the exponents are the same, they're different groups of terms. Right, so I would like you, I've helped you a little bit here. I would like you to go and simplify this expression. So basically, I want you to go and add or subtract your like terms for me. You're welcome to pop it in the chat if you're feeling confident, or you can raise your hand if you would like to share.
Let's go, my people. Alessa. We are all yours, girl.
Hello, ma'am.
Hi.
Hi.
Ma'am, the answer is 2x to the power of 2 minus 5.
Excellent. Right, so if I got ahead of myself here. When we go and look at our like terms, if we want to, we can group them together. So I've got the 3x squared minus x squared plus 2x minus 7x. All I'm doing there, guys, is putting the like terms together. Okay, and then we go and add and subtract. So we know that if I've got 3x squared and I take 1 away, I've got the 2x squared. And if I've got 2 x's and I take 7 away, I've got a negative 5x. Those aren't like terms, so I can't do anything else with it. That's my final answer. I've simplified. Well done, guys. I'm seeing some awesome answers. That's excellent. Well done. Just quickly, I can see most of you are doing it. If you're typing in the chat and you want to type an exponent, so for example, if you want to type 2x squared, you would type 2x, I have no idea what that is, but like a little copy thing. You have to push shift 6 and then you put your exponent, and that basically means 2x squared. Just so that in future you can see it. Okay, so remember, like terms, add and subtract your like terms and get your simplified answer. Right, so if you need to take a screenshot, have a look. Right, and guys, again, this is all sort of just wrapping up what we have already done. So if you are feeling a bit overwhelmed with it, please do and go and have a look at the videos on Watobe's website. So Oratile, I can see your question. It's not 4x squared because we're saying if we look at our first group of like terms, so the x squared terms, I'm saying 3x squared minus x squared. So I'm taking one away from it. So if I go to my number line, when it eventually wants to work, if I think of this on my number line, I'm currently starting at 3x squared, so positive 3x. If I take one away, I'm sitting at 2x squared. So that's where I'm getting that 2x squared from. It can't be 4x squared because I'm not adding the x squared, I'm taking it away. All right, the 5x or the minus 5x rather, this is coming from adding and subtracting the like terms with the x's. So now I'm looking at these two terms here. So those of you who want this explained, I would listen. If we again go to a number line, right, and I just have to draw enough lines here. Okay, so if we think about our number line, sorry, I'm starting to go over. I'm sitting at positive 2x. So I'm sitting on the positive 2 on the number line. I am now subtracting 5. So 1, no, I'm not, sorry guys, I'm subtracting 7. 1, 2, 3, 4, 5, 6, 7. So I'm sitting at minus 5, and that's where I'm getting minus 5x. We can't say minus 5x because remember, when I've got two negatives, that actually becomes a plus. So then we would be saying 2x squared plus 5x, which is not correct. It's not a positive 5x. We want a negative 5x. So we can't have two negatives next to each other. It has to be just minus 5x. Okay. Right, so those of you, I've now explained it again, so I hope you caught all of that. Essentially, as Yolanda has just said, we are grouping like terms, and however you choose to do that is up to you. I got the 2x squared from subtracting x squared from 3x, so the bit in orange that I've highlighted, 3x squared minus x squared is 2x squared. And then the minus 5x we got from subtracting the 7x from the 2x. So 2x minus 7x is minus 5x. Just adding and subtracting or grouping our like terms. Okay. Right, so take a screenshot if you need. And let's have a look at our next one. Tando, I see your hand. Do you have a question for us?
Ma'am, it's actually not a question. It's actually just a verification.
Okay.
So when it comes to the minus, does it go with the variable? I mean, with the entire term?
Yes, exactly.
Okay.
So the sign that sits in front of the term is that term sign. So for example, this negative over here belongs to what it's in front of. So it belongs to the negative 7.
Okay, ma'am.
X. All right, cool. And guys, just to clarify, just because I've seen it in the chat here, there is that invisible 1 in front of the x squared. So that's why 3x squared minus 1x squared gives me 2x squared, right? I'm not just sort of making things up. It's because there is that 1 there. I'm taking 1 away from 3. So I end up with 2. Okay, right. So let's have a look at our third example. This is a little bit different because there's some simplification I need to do before I start adding and subtracting like terms. So this is now where those 3 steps that we spoke about at the beginning become quite important. Now, if we have a look at this expression, someone can raise a hand or you can pop it in the chat. Can anyone tell me in the whole expression, how many terms do I have here?
Nkulumo, we're all yours. Hi, Nkulumo.
Ma'am, there's 2 terms.
Awesome, well done.
Done.
Right, so guys, there are 2 terms. Now what's really important here is the 2 terms, is from the whole expression, okay? So this minus sign inside the bracket, because it's inside my bracket, we're not stressing about it when we consider how many terms I have. This plus sign outside the bracket is what's really important because it's separating this multiplication and then the 5x. Now I'm saying multiplication because remember, when we've got a number in front of a bracket, there's actually a multiplication that's happening there. I would have to distribute into my bracket, which we'll do in a second. But multiplication does not separate signs. It's only pluses and minuses. So that's how I know that this expression has 2 terms, which I've underlined there. So now we want to have a look and say, okay, can I simplify any of these terms? Well, in this case, I can. In my first term, I've got -3 times x minus 2. So I actually need to multiply the -3 to the x and the -3 to the 2. That's really important. I need to do that first because that's the only way I can start to get or collect my like terms. Alrighty. So if you want, you can do your multiplication on the side. So what I sometimes like to do is have a little multiplication box for myself, just so that I'm very clear what I'm multiplying. Okay, so -3 times x is my first multiplication, and -3 times -2 is the second one. Now, guys, remember, when I multiply with a negative, I have to be careful. Can anyone tell me what sign I get when I multiply a negative with a positive? What sign should I get? Awesome. I'm seeing all the negatives come through on the chat. Well done. So we get a negative. So when I've got a -3 times a positive x, I get a -3. Alrighty. If I then have 2 negatives being multiplied, so a negative times a negative, I now need to remember that my sign is going to change to a positive. So -3 times -2 is a +6. So just be careful when you're multiplying with negatives that you're getting your signs correct. Okay, so now I've done the multiplication. So what I end up with is the -3x plus 6. That is just coming from my multiplication, the distribution of the -3 into the bracket. And then I've still got my plus 5x. Right, now this is an expression where I can start to collect my like terms because I don't have any multiplication or division that I need to stress about or deal with. So when I collect my like terms, I've got the -3x and the plus 5x. And remember, like I said, the sign in front of the term is that term sign. And then we've got our constant. Now, there's no other term that is a like term with the +6. So the +6 is actually just going to stay there. I can't do anything with it. But I can go and add -3x plus 5x. And I'm seeing some awesome answers in the chat there. Again, if you need your number line, that's absolutely fine. Or grab a calculator. I'm absolutely fine with you using a calculator. If we are starting at -3x and adding 5, I'm going from a negative towards the positive. So 1, 2, 3, 4, 5. And so I get a positive 2x. And then, like I say, that 6 doesn't have any like terms with it. So I just leave it as it is. So well done, everyone. 2x plus 6 is indeed your answer. Awesome. Well done. Okay. The 6 just came from the original question. I couldn't do anything with it. It came from when I multiplied the -3 and the -2. So it came from the distribution with my bracket. So when I distributed the -3 into my bracket, it multiplied with the -2, and that's where I got +6 from. Okay.
So everyone, you guys are doing really great. It's just a quick reminder. Noku, if you don't understand, you need to say exactly where don't you understand. So teacher Sam can have an idea on how to start explaining to you, okay? And also don't worry, all of these things will be recorded. Sometimes we need to watch it twice or 3 times in order for us to understand, okay? But we can clearly help you if you can tell us exactly where you're getting stuck.
Okay, guys, I just wanted to be very clear. The -3x and the +6, that's from the multiplication into my bracket. So when I multiply -3 times x, I get -3x. And when I multiply -3 times -2, I get +6x. So that's just multiplication. That's it. Then I can go and collect my like terms. Right, so that is why I've got -3x plus 6, because I multiplied into the bracket. If you're not understanding the number line, don't worry. It's just to help you add and subtract numbers. That's it. Right, you can use a calculator. You can do it how you are comfortable adding and subtracting. It's just sometimes I find that a little bit more helpful to visualize it on a number line. We don't do anything to the 6 because there is no like term with the 6. It is just +6. That's it. Okay, because there's no like terms, I can't add or subtract anything to it. It has to stay as it is. Alrighty. So if you don't have that, take a screenshot. Last time I get 2x from adding the like terms -3x plus 5x. So -3 plus 5 gives me +2x. Okay, so let's have a look here at question 4. So here we've got a fraction. There's a lot going on here, but that's okay. We've got a way to break this down for ourselves. So if some of you were in the earlier lessons in this course, we spoke about a little, I want to say acronym, I'm not sure if that's the right word, that we can remember when we multiply and divide, and that's SNV. So it's not the inappropriate SNV that you see on movies and series. It is mathematical SNV. SNV stands for, signs, numbers, and variables. And basically what it is it's a little reminder for you that when you're multiplying and dividing, to do it step by step. So you'll see what I mean now when we do this example, and we'll use SNV to divide our 2 terms. Right, guys, are we ready? So let's start with our signs. So ignore everything else, just look at the signs. So I'm going to do that in red here. We know that the 12 actually has a positive, and we know we've got a negative in the denominator. So the only question you need to ask yourself right now is, what is a positive divided by a negative? What sign do you get when you divide a positive and a negative? And I'm asking you, can someone tell me, or you can put it in the chat, what sign do I get when I've got a positive divided by a negative? Sejo, do you want to tell us?
Yes, ma'am, you get negative.
Awesome, well done. Okay, so guys, exactly, we get a negative. So that is my sign done. I've dealt with the S of SNV. I know I'm going to get a negative. Done, sorted, don't need to stress about the sign again. Now I'm going to go on to the numbers. So ignore everything else, just look at the numbers. So I've got a 12 divided by 36. Now, if you are allowed to use your calculator, you can actually just put this in your calculator and check. but it is useful to be able to do this without. So now I need to ask myself, what is the biggest number that I can divide into both 12 and 36 in order to simplify that fraction? All right, so have a think. What's the biggest number I can divide into it to simplify?
Ma'am,
Yes.
ma'am, the biggest number to divide both of them is 12.
Awesome. Well done. Right, guys. So the biggest number I can divide into both of them is 12. Now, if let's say, for example, you had said 6, that's absolutely fine. It just means that you will have to do another simplification step later on when you see that actually you can simplify further. So don't stress if you'd said 6, you'll just fix it later on. So exactly 12. So now we have to ask ourselves, okay, well, what is 12 divided by 12? 12 divided by 12 is 1. Awesome.
1.
Right, if I then think about 36, what is 36 divided by 12? Well, 36 divided by 12 is 3.
3.
And so what I've done is I have simplified my fraction, or my numbers rather, let's say that. I've done signs, I've done numbers. Now I need to deal with the variables. Now, when we get to the variables, in this case, I've got X's and Y's. So I'm just going to deal with them separately. So let's start with the X's. I've got X divided by X squared. Now, sometimes for me, I like to visualize this as a separate fraction where I can sort of expand it a little bit. So X squared we know is X times X. So if I've got 1x in my numerator and I'm dividing it by 2x's in my denominator, essentially what is happening? Now, this is going back to exponent laws that we've already covered, or you have already covered, and there's lots of different ways you can do it. The way I think of it is the 1x in my numerator can cancel with 1x in my denominator. When I divide something by itself, so 3 divided by 3 or 5 divided by 5, it becomes 1. It doesn't have any value other than 1. So I can cancel. And what I see is that I actually just have 1x left in my denominator. If you want to use your exponent laws, that's cool. Remember, your exponent law when you divide is to take the numerator's exponent minus the denominator's exponent. Now you end up with a negative exponent, but we know negative exponents means a fraction. And so that's why my X is in the denominator there. But however you choose to do it is completely up to you. Right, so I've dealt with the X's. Now I just need to deal with my last variable, which is the Y's. So a similar sort of thing here. I've got 4 Y's in my numerator and 12 Y's in my denominator. Okay, now I'm going to use the same sort of thinking. If I've got 4 Y's sitting in my numerator and 12 in my denominator, I can cancel 4 at the top with 4 at the bottom. Now, if I take 4 Y's away from the 12 Y's I have in my denominator, I'm actually left with 8 Y's in my denominator. And so now I've simplified this to negative 1 over 3xy to the power 8. Now, if you had left your answer with negative exponents, so if you'd used your exponent laws and you'd gotten negative 1 over 3 x to the negative 1, y to the negative 8. Please remember that we do not like negative exponents. You cannot leave your answer with negative exponents. You have to sort those two out. And the way to sort it out, remember, is to move it into the denominator. So negative 1 over 3xy to the power 8. We do not like negative exponents. Right? Again, I got the y to the power 8 because I have got 4 y's in my numerator. So if I just take the y's out, I've got 4 y's in my numerator and 12 in my denominator. Boy, 3, 4. Right, apologies. We've got tons of y's there. If I cancel, I can cancel 4 at the top and 4 at the bottom, and that leaves me with 8 y's in the denominator. Okay, this is going back to exponent laws. So we need to be able to do our exponent laws with algebra. Right, so I'm just gonna neatly write our answer out. Our final answer is negative 1 over 3xy y to the power 8. And how you choose to work with your exponents is up to you. If you're working with the exponent laws that you've learned, that's fine. If you want to cross cancel like I've done, that's fine. I find cross canceling easier, but you don't have to do it like that. If you want to work with your exponent laws, absolutely fine. Okay. Right, guys, we're going to take a little brain break here because you've been working hard. Oopsie, my jokes are back. We've got a bit of a different brain break today. In that, we've got some like brain teasers here. So all a brain break is, for those of you that are new, is just we take a little break from what we're doing in the maths and we use our brains to do something different. So I've got some brain teasers here. I'm just going to make this a little bit bigger so we can all see. And it's like a riddle. So you have to figure out what I'm talking about in the riddle. So the first one is, what has 13 hearts but no body? The second one is, you go at red but stop at green. What am I? And the third one is, I speak without a mouth and hear without ears. I'm invisible, but you can call for me. What am I? So have a think. You're welcome to put your answers in the chat. We'd like to hear, or you're welcome to put your hand up. I am terrible at riddles, so don't stress if you can't do this. But otherwise, get up, stretch, move your body. Oh, make sure you're comfortable to then carry on with the next one. Okay. Right, I can see some of you are wanting me to go back to the question. I will go back to the question now. All right.
Are those hands to answer? Amahle, let's hear from you.
Ma'am.
Hi.
For one, I think it's a deck of cards.
Awesome, well done.
Well
Exactly.
done.
Do you have answers for any of the others or just one?
For two,
I'm
maybe a
concerned, sorry,
robot.
Amahle, I'm interrupting you. I'm concerned that some of you think you go at red at a robot. Guys, you go at green at a robot, not red. Ay.
Exactly. You guys should be careful.
I'm worried about when you start driving. You stop at red at a robot. Ay. Okay, so we know the first one is a deck of cards. Well done.
I think Rory Sang wants to give us. Rory Sang, do you have the second one?
Ma'am, I don't have the second one, but I have the third one, but I can also give the second one a try.
Okay, well, let's hear
Okay,
what you
go
think for the
ahead.
third one.
Oh, Bulela got it.
Ma'am, the third one, I think it's an echo.
Well done.
Well done. And I
Exactly.
think we have a winner on the charts, guys. I think Bulela got it. Bulela said number 2 is a watermelon.
Yes,
Well
exactly.
done, everyone.
Okay, so watermelon, you go at red because you eat the red part, but then you stop at the green rind bit. So watermelon. Well done, guys. You're much better at this than me. I'm shocking at these. I don't like when we do these at school stuff because I'm not good. Okay, well done. Right, if you need me to go back to this question here, question 4, there it is. Take a screenshot. Guys, again, the answer where I've got the x and the y to the power 8 in the denominator is just from simplifying the exponents. That's it. So however you are comfortable simplifying exponents, that's how you do it. Okay, so take a screenshot of it. And remember, you can go back and watch this video if you want to hear the explanation again. And there are actually exponent videos on Watobe's website as well. So you can also go back and watch the exponent videos so that you're happy with these sorts of questions.
Teacher Sam, if we do have a little bit of time, do you mind just writing it all down like this? They can see it, how it cancels, but in all of it, like as in writing the numbers, the y's, the x, and then cancellation. Maybe it will help, because I had a lot of questions on this, I mean, a lot of different people asking about this question.
Okay.
So I just want to make sure that it's
right. I don't know if this will be helpful at all. I'm going to expand everything.
yes, I think that should be helpful. So everyone, if you have a question on this one, please do listen up on what is teacher Sam is doing right now, which she's expanding what it means on the questions that you can see now on the board. Okay, so you can see how we got the answer.
Sorry guys, I'm just counting. 3, 6, 10, okay, 12, right. So listen to the explanation. All I've done here, guys, is I've expanded. So basically for the y to the power 4, I've written my 4y is being multiplied. For the x to the power of 2, I've written my 2x is being multiplied. Now, this is really helpful to start off with, but obviously in like a test or exam, we don't want to waste time writing 12 y's out. So that's why the exponent laws we learn about, cross cancelling, that sort of stuff we learn about. Right, so we're going to just do the SNV quickly again. Signs, how do we decide if my answer is positive or negative? Well, let me just put my negative sign in the right place. I've got a positive 12 divided by a negative 36. Positive divided by a negative gives me a negative. So let me just take off my answer. I know that my final answer is going to be negative because positive divided by negative. Then I go to the numbers. So we said that the biggest number that can divide into both is 12. 12 divided by 12 in the numerator is 1. And then 36 divided by 12 in the denominator is 3. So I've just simplified 12 over 36. Right. Then I go to the variables. Now I'm going to start with the x's. I've currently got 1x in my numerator. And let's maybe go like this. I've got 1x in my numerator and 2 x's in my denominator. Now, this is where you're either using cross-canceling or you're using your division law from exponents, however you want to do it. But if I've got 1x in my numerator and 1x in the denominator, if I divide something by itself, I end up with 1. It cancels each other out. And so that's why I can cancel 1x at the top with 1x at the bottom. And what I see is that I've got 1x left in my denominator. Okay. Then I move on to the y's. Now I've got 4 y's in my numerator and 12 y's in the denominator. So same thing. If I've got 4 at the top and 12 at the bottom, I can start canceling. So I can cancel 4 y's, both in my numerator and in my denominator. And once I've canceled those, I see what's left uncanceled. So I can see that I've got 8 y's that I haven't been able to cancel out in my denominator. And so to represent that, I get my y to the power 8. And so that is my final answer. Okay. So that is how we can think about it. I know it's a lot, but we do need to be able to use exponents in our algebra. That's really, really important.
Okay, I think this was explained nicely. Zenakane, you can ask your question on the chat because teacher Sam has to move on to the next question. Okay.
Alrighty, guys. So, oops. That's expressions. And essentially, if you can follow those 3 steps, you will be okay for expressions. It is also just practice, right? You have to go and practice the stuff. And like I say, go back and watch the videos, go back and do the questions that we've done in those videos, and just practice it. That's all it is. Once you get used to, okay, I have to do the distribution or I have to do the fraction like this, and then I have to find my like terms, it becomes so much easier, but you do have to practice it, all right? Okay, so we're going to have a look at some equations, and we have been doing a lot of equations, and equations will be a lot fresher in your minds if you've sort of been doing this course from the start. So hopefully we can go through these quite quickly. What's really important when we are solving equations is that we are using inverse or opposite operations. Okay. That is how we solve equations. So we need to do the opposite of what the original equation did. Now, for the most part, some of these easier ones you guys will be able to look at and get the answer easy peasy. But let's have a look at how we would do this with an inverse operation format. So I've got 3x minus 2 is equal to 4. Now, guys, remember the whole point of solving an equation is to get x alone. That's what I want. I want to find what value x has in order to make this equation true. So in order to make the left-hand side equal to the right-hand side. So the first thing that I see is that I have got this plus 2. And remember, we want x terms on the left, LHS, left-hand side, and we want constants on the right-hand side. So RHS, right-hand side. So I somehow need to get this -2 over to be on the right. Now, the only way for me to do that is to use an inverse operation. So it was -2, which means I now need to +2 in order to bring it over. So I have got 3x is equal to 4 plus 2. I brought my constant over to the right-hand side. Okay, I can simplify that. I know what 4 plus 2 is. It's 6. And now I have to say, okay, I've got this, but how do I get x alone? Because remember, I don't care what 3x is. I just want x. Now, does someone maybe want to tell me, or put up your hand, or you can pop it in the chat? How am I now going to get x alone? What do I need to do? Right,
Alyssa, we are all yours.
Ma'am, we divide by 3.
Awesome, well done. And Palesa, can you tell me why I use division? Why not multiplying or adding? Why divide by 3?
Ma'am, because when you divide a number by itself, you get 1. And we
Awesome.
want to find the variable for x.
Exactly. Okay, guys, so remember, between the 3 and the x, there's that multiplication. So to do the opposite of that, I now need to go and say 3x divided by 3. And remember, it's an equation. So what I do on one side, I also need to do on the other side. So I also need to divide 6 by 3. As Palesa's just told us, if I divide something by itself, I get 1. So 3 divided by 3 is actually just 1. Now you can write 1x there if you want, but remember that 1 doesn't really change anything. So what I actually have is x, and then I've got 6 divided by 3, which is 2. And I saw some of those answers coming through on the chat. Exactly, x is equal to 2. Well done. So we use those inverse operations to solve our equations. Excellent, guys. You're doing so well tonight. This is awesome.
Well done, my people.
You're doing so, so nicely. You should be very proud of yourselves. Okay, take a screenshot if you need, so we can have a look at the second one. Okay, whoopsie. Ooh. So here we've got 3x minus 6 is equal to 18. So what I'll do is, I'll do it like this, that you can see what we did in question 1, but I would like you to try by yourselves question 2. So see for me if you can find the value of x. Just again, LHS, RHS, left-hand side, and then RHS, right-hand side. I'm just very lazy. I didn't want to write it out. I'm sorry. Sejo, do you have a question for us?
No, ma'am, I have the answer.
Answer for question 2?
Yes.
Okay, cool. Can we give everyone a couple more seconds and then you can let us know how we do it?
Okay, ma'am.
Cool. Right, I'm just going to make this bigger so that everyone can see what's happening. We've got 3x minus 6 is equal to 18.
We can do this, guys. Woo! Rory-san, was that answer the question? I think so. Hey, I think Rory-san wants to answer this one. So whenever Teacher Sam is ready to take answers, Rory-san, we are all yours. Can Rory-san answer now?
Yeah, let's hear it.
Hey, Rory-san, we're all yours.
So the first step that I did is I took the -6 and I put it by the 18, which changed into a positive 6, which is
Yes,
18 plus 6. And then it was 3x is equals to 18 plus 6. Then I said 3x is equals to 24.
Good.
Yes, girl.
Then, ma'am, I said 3x over 3
Yeah.
is equal, ma'am, then also it was 24 over 3.
Yes,
Good.
girl.
And then, ma'am, the answer that I got, it was 8.
Good.
Yeah.
Excellent.
Done. You nailed it.
Okay, so guys, remember, we're doing our inverse operation. So I want to bring this -6 over the equal sign so that it's on the right-hand side, because that's where I want all my constants to go. So to do that, I do the inverse. I plus 6. 18 plus 6 is 24. And so that's where we got that 3x equals 24. So the step over here. Now I want x alone. So what I need to do is I need to do the opposite of multiplication, which is division. So that's why I divide both sides by 3. And exactly as 24 divided by 3 is equal to 8. Well done, guys. Awesome.
Ah, she's explained it so nicely. I hope everyone understood that question.
Okay, so take a screenshot if you need. And let's do one more before we have a look at our quiz, or before you have a look at the quiz, I suppose. Right, so fractions. We love and hate fractions. It's a love-hate relationship between the two. All right. When we have a fraction, all we just need to remember is what the inverse operation is. A fraction implies division. So the inverse of division we know is multiplication. Now, in this case, I've got x minus 3 divided by 2 is equal to -1. Now, what I need to bear in mind is that the whole expression x minus 3 is being divided by 2. So what I want to try and do here is get rid of the fraction. Now, as I've just said, for me to get rid of the fraction, I need to do the inverse. So fraction implies division. The opposite of that is multiplication. So what I actually want to do here is I want to multiply both sides by whatever my denominator is, because what that does is it gets rid of the denominator for me. Remember, the inverse allows me to start getting rid of certain things in my equation. So when I go and multiply both sides by 2, I get x minus 3 is equal to -1 times 2. I'm just putting them in brackets to show that I'm multiplying. If you're happy to jump straight to what -1 times 2 is, that's fine. But we know that -1 times a positive 2 is a -2. And now this is much nicer for me to deal with. I've already got an x on the left-hand side. And remember, the goal is to solve for x. So what I now want to do is I want to get this constant to the right-hand side of my equation. And for me to do that, I need to use my inverse operations. So it was -3, it must now be +3. And so what I now end up with is x is equal to -2 plus 3. And then again, how you choose to do this is up to you. If you use a calculator, use a calculator. If you're comfortable with the number line, use a number line. If you're happy that you know what -2 plus 3 is, well done. So we know that -2 plus 3 is, as you're saying on the chat, +1. Right, and guys, remember, you can always go and double check yourself. So if you're not 100% sure about your answer, what we do is we take our answer and we substitute it back into the original question. So if I substitute this in, I would have 1 minus 3 divided by 2. And what I want to check is that it does equal -1. So I'm checking that both sides of my equation are equal. 1 minus 3 we know is -2, and -2 divided by a +2 we know is -1. And because the left-hand side is equal to the right-hand side, the answer that I got is correct. Alrighty. So you can check it like that. You do write the 1 because it is the value for x. It's not like an expression where we can have the imaginary one and we don't have to write it. It's an equation. You're telling me what answer or what value x has. So you do need to write x equals 1. That's very important. Right, guys, you will see that Yolanda's put on the chat the link for the quiz. Again, if you're new, all it is some questions for you to practice what we have spoken about in the lesson. Now, if you are new today, don't stress about being able to get everything correct. Just try it. Have a go at the questions. It's basically simplification and solving equations. So have a go of it. It's really just for you to get some practice and for you to get an idea of how confident or how you're feeling with this section. Okay, now just quickly, the 2 in the second step is coming from this multiplication here. So all I'm doing is I'm reminding myself that I need to say -1 times 2. That's all that 2 is, okay?